Hi, welcome to the Flipped Classroom. We're going to start Chapter 6, which is on linear functions, okay? So there's some new vocabulary in Chapter 6. Some of the terms that you're going to come across are things such as slope, rise, run, terms such as negative reciprocal, slope-intercept form, slope point form, and general form. So in 6.1, we're really only going to worry about these first three. That's the terms slope, rise, and run. Okay, so that's something you should key into. So 6.1 is entitled The Slope of the Line, and what we're going to learn to do is how to find the slope of a line segment, how to find the slope of the line, and then also we're going to learn how to use that information to draw lines that have specific slopes. So we'll be building on the concept from Chapter 5 about rate of change of linear functions, and you might remember that rate of change is simply the change in the dependent variable. I'm just going to abbreviate that as dependent variable, okay, divided by the change in the independent variable. Variable. Oh, well, I wrote it all the way out in one, not all the way in the other. All right, sorry about that. Some roofs are steeper than others. Steeper roofs are more expensive to shingle. Okay. So if we look at these three diagrams, and they're taken from your textbook, we've got roof A, and roof B, and roof C. And you know, just kind of quickly looking at them, most of us will realize that roof C is a heck of a lot steeper than roof B. And the steepness of a roof is related to something that we call its slope. So if we look at these diagrams, and I'm going to start with this one here, you'll notice that there is a line in blue that runs from the left corner of the roof to the middle of the roof. And that line is labeled the run. There's another line that goes up from the middle of the roof, and it goes straight up to the peak. Okay? And that line is labeled the rise. And slope of a line is defined simply as the rise, so the vertical distance, over the run, the horizontal distance. And you can see that the other two diagrams are labeled similarly. If we were to want to calculate the slope of roof A, we would simply, since they've provided us with a nice little grid, okay, all we would have to do is calculate how many lines does that rise. There's 1, 2, that's a mess, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the rise has a rise of 14. Okay, and our run, if we were to count it, we'd start over here at the far left, and we'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 as well. So we've got a rise in roof A, we've got a rise of 14, and we've also got a run of 14. So 14 over 14 is equal to 1. So we would reduce that and say that that slope was equal to 1. Okay? And that pretty much tells you that the rise is equal to the run. Okay? The other two diagrams, if we were to calculate the slope of roof B, we would say if we were to count it out, we would find that it had a rise of 1, 2, 3, 4, 5, 6, 7, 8. It had a rise of 8 and a run of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and a run of 12. Okay? So that would have a rise of 8 over 12. So 8 over 12, both of those numbers are divisible by 4. So its slope would be equal to 2/3. And 2/3 is approximately 0.67. Okay? The second roof C, if we were to do the same calculation, we'd find that it had a rise equal to 14. If you were to count that out, it's 14 vertically, and a run equal to 8. Okay? And if you were to simplify that, you'd get 7 over 4. And if you were to actually do the division, 7 divided by 4 is going to be equal to 1. 4 goes into 7 once, so the remainder of 3, so that's 1.75. Okay? So now, most of us do really have an intuitive understanding of slope. You can see in this diagram here that roof C has the steepest slope. It also has the largest number, okay? And the roof that has the smallest slope is B, and it also has the smallest number. Okay, so smaller slopes are associated with smaller numbers, steeper slopes with larger numbers. All right, we'll go on to the next example, or the next bit of information. So the slope of a line segment is really defined as the change in y over the change in x. And because that's a lot to write down, we kind of abbreviate that to rise over run. Okay, so if we were to look at this diagram here, this distance, let me just change the color of my pen. This distance here is the rise, and that's the change in y. Okay, and this distance here, the run, which is this distance here, is really the change in x. Okay, so that's how slope of a line segment is defined. Okay, so you notice that it starts at the 2 endpoints, and that there's a right triangle drawn. Okay, we want that right triangle with the square. Let's go on to our first example. Example 1 says determine the slope of each line segment. Okay, so in our solution, which starts here, the instructions are count units to determine the rise and the run. So if we were to count these units here, I'm going to start at this lower point here, and I'm going to count up until I get even with this point here. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And so you can see that we have a rise of 9. It's marked in there. Our run, maybe I should write that down so that we've got a record of it, since times is equal to 9. Our run is 1, 2, 3, 4, 5, 6. Our run is equal to 6. And since slope is defined as rise over run, fill in our numbers. So we've got a rise of 9 and a run of 6. Right, so 9 over 6 can be reduced. Both 9 and 6 are divisible by 3, so you divide the 6 by 3 and you divide the 9 by 3. 9 divided by 3 is 3, 6 divided by 3 is 2. And so 3/2 is a perfectly acceptable way of leaving a slope. If you want, it can be expressed as a decimal by taking the 3 and dividing it by 2, and you get 1.5. So that line segment, EF, has a slope equal to 3/2 or 1.5. We don't tend to leave our slopes as 9 over 6. Okay, if something can be reduced, we do reduce it. So let's look at part B of this example. If you look at that, you notice that the line, as it moves to the right, is going down. Okay? So we know that we're dealing with a negative slope. Okay? So I'm going to start here at G, and I'm going to count down. I'm going to count down 1, 2, 3 units, and and that brings me even with h here. So this is 3 units, and since we're moving down 3 units, we give it a negative sign. Okay? So that's -3. Our run is going to be equal to, so we're just going to start here and count 1, 2, 3, 4, 5, 6, 7, 8, 9. Our run is 9. It's labeled right there. So we've got a run of 9 and a run equal to 9. And so slope of that line segment, GH, is going to be equal to -3 over 9. That's going to be equal to, now a negative divided by a positive is a negative, so the overall slope is negative, okay? 3 and 9 are both divisible by 3. 3 goes into 3 once and into 9 3 times. So that slope, the slope of the line segment GH is equal to -1/3. Okay? Well, let's look at